Okay, welcome back. We are going to talk about 8.2, which is volumes of solids of revolution. And there are two strategies, disks and washers, that we'll be discussing. Now, I first want to preface this by saying, first thing, you should definitely watch that animation video because you need a visual idea of what you're really doing here. I'm trying to show you a 3D volume on paper, which is two-dimensional. So some of that gets lost in translation. Fast forward on that video to like minute 3 where the animations occur. Okay. He also does a great job explaining the visual difference between a disc and when you want to use a washer method. Okay. I'm going to teach you how to do the mathematical strategies, but that visual strategy, even in class, I had a disc on a CD and I showed them this animation every year. And so it's just really helpful. I can tell you as a student, when I was in calculus, this was the hardest topic for me, and I totally had no clue what it meant. So that's why it's actually one of my favorite topics to teach because I understand what it is. Second disclaimer. This section, it is one section in a textbook, but in a classroom, I would spend 3 to 4 days on this section, okay? So if you need to watch some of the video, take a break, watch some more of the video, take a break, because this is going to be a long video, you definitely should do that, okay? This is a mandatory tested topic. And it's not super complicated, but it does take your brain a little bit of time to process what you're doing. If you pick it up quickly, that's even better. But if you don't, please know that you're not alone and that with time and practice, it will help. I will tell you, my assignment that I'm giving you is definitely a lot shorter than I would have given in person. Like I said, we would have spent 4 days on this. And they would have had practice problems every single day. I would have walked around talking to students, stuff like that. So, all right. I also do not want to split this up because you need to get familiar with knowing which strategy you need to utilize. Okay. And so that's why I want to keep them together because that's part of the learning structure. All right. So let's get into it. I'm so sorry for my 3-minute introduction. I think you need to know that. All right. So, the discs and the washers, these are the two types. Whoops. And they look very similar because they are. So the way it happens, the main difference between a disc and a washer is a disc, which is on top. This one is a washer. A disc is completely solid. So you can think of, if you had a shape, could you pour any water into this at all? And so, no. Okay, that's the idea behind a disc. A washer, it's easy to remember because a washer is like your clothes washer. You can put water inside of it, okay? Now, the hole doesn't have to be looking like this, okay? The hole also does not have to go all the way through the object. But if you can put any water at all where there's any holes or gaps in this shape, then it is a washer strategy, okay? So I'm going to put can put water in, okay? No water. So that's the first thing you ask yourself, okay? Now, what we're doing on both strategies is, and you might not know this, but if you have like tools and nuts and bolts out in your garage, there is a little silver disc called a washer. And so it's circular and it does have a hole in it, okay? So the idea, and that's where washers get their name, is we want to take a thin circle, whether it has a hole in it or not, it doesn't matter. We're going to take thin circles and we're adding them up. So when I integrate, I'm really integrating the areas, which because they're circles is pi r squared. And so the pi is constant, so we can put the pi out in front. and we have a radius squared. So remember, radius, though, is from the center to the edge. Now, the center is not always going to be on the axis. It typically is. So what's going to happen is you're going to find a region, and he explained this on the video. You're going to find a region. Let's say I'm taking the square root, okay? We're going to chop it off. The equation that they describe, you're going to graph out, and that's going to be your solid shape. So if I was going to spin it around, they'll tell you the axis that you revolve it. And so the region you spin it on, when I draw it, I always draw it dotted. That's going to be your radius. So typically it will be to a certain line. Now the axis is used a lot, but I like to say that it's not always the x-axis because we might move that axis of rotation. So don't get used to that, okay? So notice pi is always out in front on discs and washers, and then we have some kind of r squared. Now the way I think of r, and I didn't make this up, I don't know who did, but it works for me, is I don't remember r, but on a disc, to get my radius, I'm going to think of top minus bottom. So if it's along the x-axis or anything parallel to an x-axis, you're going to think of pi a to b of top minus bottom squared, okay? But not top minus bottom of the whole shape. It's top minus bottom of the radius, okay? So I think of this as, let's call this whole. But it's always, I don't do my revolved area. You'll see in a second. Now, we can also do the same thing in terms of y's. We saw that with area. And so if we're stacking our discs, like you want to turn your paper sideways, like we're going up and down, then same idea, we still want to do right minus left. Now, because we're squaring this, it actually won't matter if you do right, left minus right. But to keep it in good faith, go ahead and do right minus left. And that one's simple. Discs are going to be a lot simpler, but I can do setups that get a little tricky. So just be patient. All right, now on washers, same idea, except when we go to do our radius, okay, I have this outside radius and I have to subtract the hole that I don't want, because the way the outside radius works is it acts like that's solid, and then you're going to take off this part that isn't solid. And so I think of this as the r is my hole with the w minus my hole without the w. Okay, and so I really do write that. So I've got pi a to b, and this is all in one. So now notice they are going to get squared separately. So we're going to do whole, oops, sorry, I need to erase this. Let's do black. We're going to do whole minus whole. And so we're going to have a top minus bottom and top minus bottom. And same thing, I could do it in terms of y. So I might have right minus left and right minus left in terms of y. Okay, so whole minus whole for washers. So the hardest part for you is going to sketch it, figure out if it's a disc or washer, and figure out what your top and bottoms are. That really is a lot harder than it sounds. Like I said, some people get it quickly, some people don't. So once again, how do you know which variables to use? So it's whatever you're rotating it about, what it's parallel to. So if it's parallel to something that's a horizontal line, then you use x's. If it's parallel to the y-axis or anything vertical, you have to use y's, okay? And so these typically are going to be simple equations because you might have to get them in a different variable. All right, I am definitely going to do a ton of examples. This is going to be a really long video, but I think the more you see, the better. It makes it easier. So there's 3 examples here, 6 examples, and actually I gave students in the classroom like 5 of these so they could see all the differences with the setup, okay? Now, if you want to skip some of these examples, I totally get it. That's 9 examples. They're very similar, although I think you definitely should watch them. But you will want to go and fast forward to see me work through the exceptions. Okay? So these exceptions have something different about them that's often missed. Okay? And I only have 2 varieties. So then you'll see your student practice. I decided not to have you do problems like that. And I just said, let's just mix them all up and we'll give you multiple choice. That's what you're going to see on the AP exam. So I gave you 6 problems to do all together. Okay. And like I said, after the 6, if you need more, I definitely can send you more, but I think try those 6 and see how you do. All right, well, I'm going to go ahead and start in on this. So my strategy, it's very straightforward. It says find the volume. They give you some functions, and these should be functions that you can do without a calculator. You should know what they look like. So y equals x squared is a parabola. Y equals the cubed root of x. I call it my sideways snake. And we're going to rotate it around 3 different things. So the first thing I do is I'm going to sketch what it might look like. And so it's always the bound region. So I'm looking at y equals x squared. Oops. I'm going to try to draw that as best as I can. Y equals the cubed root of x. Okay. And so I'm really looking at this region right here. Now, I am going to blow that up. So let's make, and then on my next ones, I can just already make it bigger. And then I'm going to draw my axis because I do care about the axes. Okay, so I'm looking right there. Okay. So what I'm spinning it around is the x-axis. So I always like to note that to myself. And so this is my original bound area. And so you want to mirror image that on the other side. And I always make it dotted because it's not really there yet. And so if we spun this around, it would kind of be like a bowl with like a curvy inside missing. So it would be able to hold water. Okay, so that's the first thing you want to determine. So this is definitely going to be a washer. It's really a cool shape. If you really like pottery, this is totally up your alley. So you got to imagine like this is on one of those. Is it an urn? It's not an urn. I don't know what it's called. One of those pottery wheels. And so the outside is a really smooth bowl. And on the inside, it's kind of like this V-shaped all around. Okay. So if that's a washer, I'm going to set up its pi. Everybody forgets pi. We can do in one integral. And if it's around the x-axis, we're going to use x's. Okay. So dx. So I'm thinking of whole minus whole. So something squared minus something squared. Okay, get it all set up so you know like, oh, I know I need to know more. Maybe I don't know what it is, but. So on my whole, what I do is I don't worry about anything under the x-axis. So I take, because it's a radius, I just look at the original region that was sketched. And so the whole, it always goes to the axis of rotation. So on my whole, I would take this rectangle. So that's my whole. So it's top minus bottom. So like we're going to act like that was solid, like that purple curvy part's not there. So my top curve is the black one, which was that cubed root, minus the bottom is the x-axis, which is 0. I do write it, so I know I've done top minus bottom. My next is going to be the hole that's gone. So I go to anywhere there's a gap, and I don't go to the edge because it's kind of hard to tell. I always go in the middle. And I say, okay, well, what is the actual H hole that's missing? And so it's all of that region. And so I've got top minus bottom. So the top is touching that purple curve, which was x squared. And the bottom is still touching the axis. So if you're rotating around something else, you might see how we would be putting in a number instead of 0 every time. Okay? Now, at this point, you don't really need to clean that up. As long as you set it up, you can go ahead and go back to your calculator and do that math function. So you don't want to use the graph because we're not being bound by the x-axis, so it won't be accurate. So we're going to go to math, number 9. We didn't find our limits. I knew I'd catch myself. So our limits, if we set these equal, sometimes you can even tell, well, I know it's going to be 0 because 0 squared, I'm looking for when does x squared equal the cubed root of x? And so yeah, 0 squared equals the cubed root of 0. And then it's got to be a nice number. So I just tried, hey, does 1 work? 1 squared is 1. The cubed root of 1 is 1. Yeah, it's 1. Okay. Now in my calculator, I don't put in pi unless I have to. So I'm going to leave the pi off. So we're going to go from 0 to 1. I've got, if you want to rewrite this, you can, but I'm just going to type in the cubed root. So I get x to the 2/3 minus x squared is x to the 4th. It's just easier to type it in. So x to the 4th. But you try typing it in however you want, and we'll see if we get the same answer. All right, so I got 0.4000. I'll write it down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 3, 6, 7, 8. Okay, so they might see this written as a fraction. My calculator's not giving it to me, or they might have multiplied that by pi. You just got to be flexible. So let me go ahead and type that in. And I got 1.256. Remember, I just chopped mine off. I don't round to 7. Now, could we integrate that by hand? Definitely. We just don't because of time. All right, let's do the same thing, but now let's rotate it around the y-axis. So I'm still looking. Let's go ahead and keep purple. We've got the x squared. And we've got the cubed root. And now we're spinning it around the y-axis. So because we're around the y-axis, we need to use y's. And I'm going to go over here. And so we have the same bowl shape, but instead of being sideways, it's going to be up and down. Okay? So I still know I'm going from 0. And I know if x is 1, well, 1 squared is 1. So the y value, it's just a coincidence, is the same. So what's kind of nice is you would have the same integral. Now, some people say, well, won't it just be the same? Well, you have to think. If I'm going to spin it around this way or this way, it really depends on the region and your limits. So sometimes if I was going, like if this was at 9, then I might be at like 9.3. And so it might be longer one way and shorter the other. So I don't always think they're going to be the same. Okay, it really depends on the shape, the region, the limits, everything else. So keep that in mind. So when we go to do our whole minus whole, because this is a washer, we need to think of sideways ones. So this is my whole. Remember, you're going to act like it's solid to the line of rotation. So we're going to do whole minus whole, and this is right minus left, right minus left. So my right is the purple, so the purple is the squared, minus the left is 0, and then minus the whole is what's missing. So the right is the cubic minus the left squared. Oops. Oh, I totally said it and then I didn't do it. So remember, these need to be in terms of y. So if I know y equals x squared, I can take the square root. And so x equals plus and minus y, root y. And so I have to think, well, remember, we were only using half of that curve. So this was the positive root y, and this is negative root y if it's over there. So I'm looking at positive square root of y. And then here, I'm going to cube both sides. So x equals y cubed. So there we go. And this is dy. I caught myself when I was going to write dy. See, it happens. Good thing. So now I look and I say, you know what? Well, I don't know. These aren't the same equations that I'm integrating. So would I get the same answer? I wouldn't think so. I mean, it's going to be close. So once again, I'll leave the pi. Actually, I'll go ahead and just put it in. So pi, and then I'm going to do math, 9, 0 to 1. I'm just going to do the square root of y squared is y, but remember use x, minus y cubed squared is y to the 6th, so x to the 6th. Okay, so I got 1.121. Okay. If you need to match this up, you would need to integrate by hand. We've seen that. I'm just doing this for time. Okay. Last one on this is if we rotate it around y equals 1. So I've got this and this. Remember, that's at 1. And the line y equals 1 is horizontal. And so that would be touching. And so we're going to spin it around here. So I'm going to get another bowl shape, but this time it's going to be opening up on, like the hole goes in on the left. Okay, so it's still a washer. You really won't be able to go from a washer to a disc if it's the same shape. So, but it depends on the regions. Just be careful. The line y equals 1 is parallel to an x-axis, so we're going to use x's. So my x limits are 0 and 1, so pi, 0 and 1. We've got whole minus whole, and it's with x. So the whole thing, always use your original. So the whole thing, you're going to act like that's solid. So that's my whole. I'll make a W. So remember, it's still top minus bottom. So the top is touching 1. The bottom is touching that x squared. And I can't just square each of those. So we definitely are going to want to type that in how it's written. Minus the whole that's missing. I'll just draw it here. That's my h. And so same thing, it's top minus bottom. So, s squared. My top is touching 1, minus my bottom is touching that cubed root. So, cubed root of x. Let's go ahead and make this bigger. Oh. All right, I wanted to zoom in. Okay, so we're just going to type all that in. So, pi math 9, 0 to 1. You will have to add an extra parenthesis. So 1 minus x squared, parenthesis squared, minus parenthesis 1 minus, you can find the cubed root under math. So cubed root of x, close your parenthesis, and then square it. So make sure everything gets typed in correctly. That's really like the biggest issue. Dx. Just double checking. 1 minus cubed root of x squared pi. I got 1.361. Okay. So all of these are very similar volumes, but they're not exactly the same. Okay. The way the AP grades it is you get 1 point for the setup and then 1 point for the decimal answers. So, okay. All right, I got to move this back. There we go. All right, so on these, they're going to look very similar, but I've got 6 different things. So let's go ahead and we'll just do it up here because I have some room. So we get 1 plus root x. I'm going to go up 1. And remember, root x looks like that. So that's 1 plus root x. Y equals 1. And then x equals 4. Okay. And so it's always the region that's bound. So we're looking at this little region. Okay. And so I've got 6 different scenarios. So if we rotate that around the x-axis, let's draw a picture. We've got this region. And I want to spin it around here. So I'm going to use x's. And it's going to look like this. So if I spin this around, I actually am going to be able to put like a can all the way through. Okay, so it's definitely a washer. But anytime you have a gap, doesn't matter if it's all the way through or not, it is a washer. Okay, so visualize that. It's a bowl on the outside, but you can put a can, it's like a cylinder on the inside that's missing. So if I'm going to the x-axis, that's going to be my whole minus my whole. Does that make sense? So we know we're going from 0 to 4 because that was one of my limits. So we've got pi, 0 to 4, and then whole minus whole. I do like to set that up. So something squared. I put it in because everybody forgets to square it. It does happen. So because we're using x's, it's top minus bottom, top minus bottom. So the top of my w is the curve, so 1 plus root x, minus the bottom is the x-axis. And then my whole is touching at 1 minus 0. And so we could find the whole disk and then subtract off the volume of a cylinder, but who wants to do that? Okay, this one you definitely, because you would not be foiling or doing any of that cleanup by hand. This would definitely be a calculator question. I like to get the answers so you can check to make sure you're plugging them in correctly. So number 9, 0 to 4. So add in an extra parenthesis, 1 plus root x squared minus 1, because 1 squared is 1, dx. So it really depends. It might be 18 and 2/3 pi, I don't know. But 6, we'll just put 6 pi or multiply by pi. So 58.643. There are a lot of decimals on your homework. All right, the next one. We've got this region. Here's 1. That's at 4. And we want to spin it around y equals 3. So if x equals 4, 1 plus the square root of 4, that's 3. So this ends at 3, and so I'm actually going to spin it around that line. And so on the outside, it's going to look like a smooth cylinder, but on the inside, we have that curvy kind of tulip part missing. So either way, though, we're spinning it around something parallel to an x-axis, so we want to use x's. And it's a washer, because I can put water in it. So pi We still want to use x limit, so it's still 0 to 4. And it's going to be whole minus whole dx. Okay. So I think I'm going to use the purple. I ignore the pink because that was my reflected or revolved region. So I'm going to go here. So the whole thing is right there. And the part that's missing is right there. So my top is touching the line y equals 3. So top minus bottom, top minus bottom. So 3 minus the bottom is touching that line of 1. Okay, so I really do think these drawings help. The next one, my top is touching 3 minus the bottom is touching the curve, which is 1 plus root x. All right. Pi math 9, 0 to 4. We got 2 squared minus parenthesis 3 minus parenthesis 1 plus root x. Yeah, this is going to be a really long video. I might have to stop it and then restart it. Like I said, we would spend a few days on this. This is just tricky. Hold on. Okay, 1. Oh. Like I said, I'm just making sure I have all my parentheses. I'm missing. Yeah, okay. I'm just double checking my calculator. Okay, so I got 41.887. All right, the line y equals 1. So we've got right here. Now, this is our first disk. Because if I reflect that, it's like a bullet. Okay, that's what I think of. So there won't be any water. There's no holes at all. Okay, it's parallel around something that's parallel to the x-axis, so we want to use x's. But this is our first disk. So it's only half of what we are. We still want to use x limits, but now I'm just going to do the top minus bottom. So it's just the whole part. So the top is the curve minus the bottom is 1 squared, and it's still dx. So pi 9, 0 to 4, and let's see, parenthesis 1 plus root x. I know I could simplify. I'm just choosing not to. And then minus 1, parenthesis squared. 25.132. And it should be less. It's a smaller region that we're doing the volume of. Okay, the y-axis So now we're going to spin it around here, which means we want to use y's. And so we're looking at this shape. So this is going to be a wide, smooth outside, and I can put water on the inside. So this is still going to be washers. So this was 1 plus root x. So remember, this was at 3, because if x equals 4, y equals 3. And so we're going from pi from 1 to 3. And we're going to do whole minus whole, but dy. And so we're doing right minus left, right minus left. So we need to solve this in terms of y. So we're going to subtract 1. And then square both sides. Okay. So my whole is my w. And then my whole, let's just do this. That's my h. So on my whole, I've got the right is actually touching 4 minus the left is touching 0. So you want to act like that's a solid cylinder. And then my whole that's missing, my right is touching the curve, which is now y minus 1 squared, minus the left is touching my axis. Okay, so go ahead, and when you put it in, you're still just going to put in x's in the calculator. So 1 to 3, 4 squared, so 16 minus parenthesis x minus 1 to the 4th power. And it should be pretty big, 80.424. All right, similar. 1, 4, 3. The line x equals 4, so that is this line. And so we would go over here. Okay, so it's going to look like, I don't know, a top? A hamburger bun top. How about that? So this is going to be a disc. We're spinning it around something that's parallel to a y-axis, so we do want to use y's. So we still know it's pi. Our limits are going to be 1 to 3 because those are y values. And it's just going to be the whole part. So remember, it's around what you're spinning it. That's the hardest thing for students to realize. Okay? I draw that for the shape to see if it's a disc or a washer, but we don't use that to set up our integral. So the right is touching the line, minus the left is touching the curve. So remember, that curve is y minus 1 squared. And then this is still squared. Now I'm not going to be able to simplify that, so I need to use a lot of parentheses in my calculator. So pi, math 9, 1 to 3, and I'm going to add in a parenthesis. So 4 minus x minus 1 squared, parenthesis, square that again, and then dx. So I got 53.616. All right, let's move over a little bit. You can kind of see I have 5 different answers so far. Last one, and then I will take a break from this video. So 1 to 3. And so we're looking at x equals 6. So if this was x equals 4, x equals 6 is about right here. That's what we're spinning it around. So let's go ahead and move this over a little bit. I would flip this region, so I'm going to keep it dotted. And if we spun it, we would have a can in the middle. So I'd have a hamburger bun with a can cut out of it, basically. So always go to your axis. So this is definitely going to be a washer. We're spinning around something parallel to the y-axis, so we want to use y's. So my hole, it always goes to the axis of rotation. That's my hole, minus the part that's missing. Okay? So pi, we're still going from 1 to 3 because they're y limits. And we're doing hole minus hole. So it's still right minus left. So right is touching 6 minus the left is touching the curve. And that's squared. Minus my hole, the right is touching 6. The left is touching 4. Squared. Pi. Math. You can see why it took us a few days to go through this. These are not quick problems. They're not quick problems to understand either. So 6 minus parenthesis minus 2 squared is 4. Woo, that's a big one, but that is kind of the biggest. Okay. All right, this is 42 minutes, so we are going to go ahead and take a break before we get to the exceptions. Okay, so I'll put a little note because I didn't realize that's all. Actually, let's just keep going. I only have 2 left. You can pause. Okay, so on the exceptions, obviously something might happen. So we have the same curve, because that's not what is the exception. So 1 plus root x. 1 plus root x. We've got x equals 0. Y equals 0. And x equals 9. Okay, and so they wanted to show that we were looking at, we really didn't need this, but that's okay. We're looking at this region right here, okay? And so I'm going to draw another one over here just because I know we're going there. Okay, so on the first part, if we want to spin it around the y-axis, well, that means we are using y's. So we know that this is going to be y minus 1. We know this is going to be from 0, though, until, so if x equals 9, we can plug this in. So 1 plus root 9, so that's 3. 1 plus 3, so that's 4. So now this one's going to go to 4. So we want to go from 0 to 4. Okay, but what happens is if I spin this, let's erase this before we talk. If I spin this around the y-axis, I've got this shape. And so when I go to draw in my hole, I've got the whole thing is right here, okay? And even if I drew it up here, it would still be the same because it would be right minus left. The right is touching 9, the left is touching the axis, okay? When I go to draw my hole, okay, so if that's my hole, my right is touching the purple, my left is touching the pink. But what about down here? And so it says, you know what? We don't have a hole that's missing when y is less than 1. And so we won't always be touching the same thing. So what that means is we need to split it up where it's different. So right here is kind of where it's different. So down here, I'm going to have a disc. And from 1 to 4, we're going to have a washer. Okay? And so we're going to have a lot. We're going to have 2 integrals that we have to do. So for my disc part, we can integrate. It's still from 0 to 1. There's still y values. And it's just right minus left. So right is 9 minus left is 0 squared. Okay? And that will give the volume of the bottom region. It's solid on the bottom. There's not a hole all the way throughout. And so whether or not we realized it, our other holes went all the way from top to bottom. So now the washer part, we're going to set up another hole. Okay. So I'm still going from 1 to 4. And I've got hole minus hole. So the hole on top, the right is still 9, minus the left is still 0. And the right of the H is the purple, minus the left is the axis. Okay? So I'm not even going to type that in, but this is what we're going to do, just because we're already long on time. All right, so let's do that same region, but now we want to revolve it around x equals 9. I'm trying to get smaller. There we go. And so if I do that, so here's 9. So I want to spin it around that, which is parallel to y-axis. So we're definitely going to use y values. And I'm going right here. Okay. And so this is going to be a solid hamburger bun. But what happens is if I draw my radius right here, the right is touching 9, the left is touching the axis of 0. But what if I drew my hamburger bun here? I'm sorry, my radius here. My right is touching 9 and my left is touching the curve. And so because you're touching different things, we have to split this one up where it's different. So it's different right at that one. So now we're going to have a disc and another disc because it's still solid on both parts. Does that make sense? So I've got pi. We're going to go from 0 to 1. And it's still a disc, so it's right minus left. So the right is 9, the left is 0 on that entire bottom portion. And then we get from 1 to 4, it's another disc. So the right is 9, and the left is the curve. Okay, so those are the exceptions. And the only way to know that is with practice. And so that's why I give this to you. Okay, this has been a long section. It's still one of my favorites though. So definitely try your practice and let me know. I can send you videos of anything. I can get on a one-on-one Zoom and do some help with you. All right, good luck. I hope you like it as much as me.